Next, I'll tell you the basic principle of slip in the induction motor. Okay, slip has a very important role in induction motor. First of all, you should know what is slip. Slip is basically that is ns minus nr divided by ns. Ns is what? Ns is, we can say it as a stator speed. Okay, that is in always rpm. NS we also called it as a synchronous speed. Okay, why we call it as a synchronous speed? Because these speed are the constant speed, we can't change the stator speed. Next is the rotor speed. Nr is denoted by the rotor speed, we can change the rotor speed. Okay, slip is always in percentage, so we'll multiply always by 100, right? Clear? So we can have from this slip, like we are having this formula of slip na. Ns is equal, sorry, S is equal to ns minus nr divided by ns multiplied by 100. If I want to calculate rotor speed formula from here, then what we'll get? Nr is equal to ns into 1 minus slip. Okay, because in the numerical they'll generally ask you calculate the rotor speed if slip is given and synchronous speed is given or stator speed is given. So this formula comes from here only. If generally slip, like it is a fixed, that slip values always lies between 0 to 1. Okay, for the motoring operation. Motoring operation, if you're, because you, if you know about it, your same machine can work as a motor also. Okay, and it work as a generator also. Okay, because both construction must be the same, motor and generator construction is same, only there is a difference in working principle. So uh, slip values always lies between 0 to 1 in case of motoring operation. Now if nr is equal to 0, when is nr is equal to 0? At standstill operation. What is standstill operation? Remember, when we have studied this induction motor basic principle, I told you whenever we'll give the supply in the stator, after some time rotor is still stationary, right? After some time only rotor keeps on rotating, but in starting rotor is still stationary. So if rotor is stationary, then the speed of the rotor is what? 0, right? If nr is equal to 0, if I'll put nr is equal to 0, then in that case slip value would be equal to ns by ns multiplied by 100. Basically that slip value would be equal to 1. Okay, if nr means rotor is not rotating, then in that case slip value is equal to 1. Next case, if ns is equal to nr, okay, means in this case if suppose stator and rotor are in the same speed, thief is also moving in the same speed and police is also moving in the same speed. If both are moving in the same speed, then tell me, will they able to catch with each other? No. So if ns is equal to nr and I put the value of this, then s slip how much will get? That is slip will get 0. Why? Because s is equal to ns minus nr divided by ns. So if ns is equal to nr, then slip would be always equal to 0. Okay, now in which case slip is greater than 1? Slip must be greater than 1 for the plugging operation. We can call it as a plugging also. Okay, and we can call it as a braking also. Plugging or braking. Clear? So slip will be greater than 1 for the plugging, and slip is negative side. Slip is negative 1 when induction motor will work as a generator. Okay, I told you slip values generally lies between 0 to 1 when it work as a motor. Slip will be negative when it work as a generator, and slip will be greater than 1 when will be work as a plugging or braking. Okay, So if slip will consider, then there is a difference in the formula. What is the difference? In that case, frequency will also change. Okay, then in that case, frequency of rotor, that is denoted by FR, that would be equal to S into F1. What is F1? F1 is the stator frequency. Okay, like in this case we are having two frequency. One is the frequency of the stator and another is the frequency of the rotor, right? Another is the frequency of the rotor. So basically, if we want to calculate the rotor frequency, then that would be equal to slip into F1. Okay, similarly we are having different EMF in consider of slip, that is E2R is equal to S into E2. What is E2R? E2, 2 means the for the rotor. Like if you have studied if you have studied about, in case of induction motor, it also works like a transformer. Okay, in transformer, primary winding will consider it as a 1 and secondary winding will consider as 2, right? Remember, in transformer, primary winding will consider as a 1 and secondary winding as a 2. Okay, so in this case also it is a rotor and a stator. Can you tell me, stator work as a primary winding or secondary winding? Primary, because we are giving supply to the stator, and in the rotor, rotor work as a secondary winding. This is the same principle. In transformer also will give supply to the primary and automatically EMF is induced to the secondary, right? In this also will give supply to the stator and automatically EMF is induced to the rotor, right? So in that case, E2R would be equal to SE2. 2 for secondary and R for running. If the rotor is running, then that would be equal to this slip formula. Clear?